All right, today I'm going to show you guys a little bit about laminar flow and turbulent flow, and then we're going to go inside and take a look, and I'm going to lay some stuff out on a whiteboard and describe both of them and let them know why they're important for your clean room and your design considerations and your industry. So let's start out with non-laminar flow. As you can tell, it's loud. When I put my hand on it, it's splashing everywhere. It's going in every direction, and you know, it is turbulent. You can see it. Also, the other thing is it's very loud as it enters into the bucket there. So now I'm going to go over here and shut this off. I'm going to climb down. I'm going to pull this patch off, and we're going to take a look at laminar flow. Before I do that, I'm going to let this water stabilize so it's not sloshing around, because that'll disrupt the laminar flow. You really want it to be as stable as possible. And then I'm going to pull this patch off, and it's going to look a lot more like ice. The direction of the flow is going to flow in a uniform direction. And you can see how quiet it is as it enters in. It looks like glass right here. It's, you know, I know exactly where it's coming out. If I put my thumb on it, it fans out in a uniform direction. So that's the difference between laminar flow and non-laminar flow, and you can hear it as it enters into the water down there. It's a lot clearer. It's not disrupting. It's moving in a same direction, same velocity. Looks like ice. All right, let's go inside. Let's take a look. All right, following up here on our demonstration we just did outside with the laminar flow with the water in the buckets. So now I'm going to talk to you about what laminar flow means for clean rooms, and hopefully what it means for your application, your industry, and what you need to, some design considerations you'll need in building your clean room and what kind of equipment you'll install in your clean room based on the industry you're in. So a couple of things to recap what we were talking about outside is laminar flow. It's uniform direction and velocity. No eddies or swirls. So this is an eddy. These are some swirls. This is you know, all stuff that if this air gets moved back up, you know, to a workbench level, it could bring contamination that's on the floor back into the clean room here, and really what you're working on your workstation, and that's what you want to avoid. And so the fluid layers are sliding in parallel, as you can see, they're all falling. And with this, we have a perforated floor, and so the air is going through the floor. It's a raised floor. This is an example of a raised floor tile. This is a 2x2 tile right here. And you can see a lot of perforation, a lot of room for air to flow through this. And it really helps clean rooms breathe. However, the challenge with this is it's really hard to clean. And so it's not the best for certain industries and certain applications. In particular, industries that are needing to comply with pharmacy regulations and CGMP, FDA CGMP regulations. Perforated floors don't comply. They're not easily cleanable. And so for those applications, you're going to need a welded vinyl floor. It's a flexible material. However, there's no breathability in this. We'll cover your whole floor with this, and we can cove it up the walls so that it's easily cleaned. There's no corners. So if this whole floor is covered, then there's no room for air to flow. So clean rooms need to breathe. They need to have a return. They need return air. And if they don't have return air, then you're going to have eddies, or you're not going to have proper airflow required to maintain your ISO level. So in the event that you're not doing a laminar flow, a true laminar flow, and you're going to get rid of the perforation on the floor and put in a welded vinyl floor, then we can take a look right here. And here's a low wall return that was just added in. We'll get rid of this over here. So there's a low wall return. Here's another one. And so now, with this, the airflow has the ability to exhaust and leave the room via, wrong color, low wall returns. And so this is going to start moving air out like this, and as it gets closer, it's going to start pulling more, and it's going to be exhausting just like that, okay? And so this gets rid of your laminar flow. This air is eventually going to return up to these HEPA filters, and you know, this is a simplified version. Eventually you're going to have some cool air or HVAC added in. This is just a general description of a non-laminar flow. here's what, laminar flow looks like. Parallel lines, uniform direction and velocity. This is turbulent. So when you have low wall returns, you're sacrificing to a certain degree. There's going to be parts that's still laminar. The closer you are to your HEPA filters up here, the more laminar the flow will be. As you get further, eventually all that air needs to exhaust through a single or a couple of points of exit, and it can't just go straight through the floor. So our mobile clean rooms, some of our mobile clean rooms are designed for pharmacy compounding, clinical trials designed with CGMP regulations, and those are going to have the welded vinyl floor. Other of our clean rooms, mobile clean rooms, and clean rooms that we can build for you, whether it's a custom modular clean room or one of our instant clean rooms, some of these other options we can design them with perforated floors. Really depends on what industry you're in. Now, if you're in the biotech industry working on a clinical trial, laminar flow is still very important for you, but so is cleanability. And so if you're not going to have a perforated floor, how are you going to maintain laminar flow? While also, it'll be better to clean, it'll be a lot easier to clean, but now you're not going to have laminar flow. So what are we going to do about that? That's where it's really important to consider biological safety cabinets and laminar flow hoods. These are great devices. Now let's just introduce one right over here. These are great. They serve a great purpose, and if maintained properly and properly installed and not damaged, they can provide very clean air, 99.995% efficient air at 0.3 microns over your workstation directly. And it's a lot less susceptible to airborne contamination because it's a dedicated small laminar flow workspace put inside of a larger clean environment. So let's just put a laminar flow hood right here. This has got, there we are. Now, laminar flow hoods are either vertical or horizontal. Let's just make this a vertical one, and we'll just put a HEPA. This is vertical. So right there, in this situation, we're going to have laminar flow going right over a workstation, just like this. And it's a lot less susceptible to turbulence in the entire room because it has its own dedicated area that's just maybe 24 inches above what you're working on. If you're working on something right here, it's going to be providing clean air that's HEPA filtered right over your workstation. And biological safety cabinets and laminar flow hoods certified ISO 5. So that's incredibly clean air right over that workstation. And in that case, now you have a non-laminar flow room, a turbulent room, but your critical area, where really your most critical area, is going to be laminar flow. And so now this entire space is cleanable. Although it's not laminar flow, it's going to be ISO 7 most likely, if not ISO 5 for more aseptic processing. So, but your critical area will be laminar flow and it will be cleanable. So you get the best of both worlds. There's also horizontal laminar flow, and this is a clean room we built for Lawrence Livermore National Lab when we were working on their national ignition facility. And let's remove these. Let's just remove this whole thing actually. So horizontal laminar flow is pretty much what it sounds like. It's when the air flows horizontally rather than vertically. It really depends on the application and what you're going to be doing inside of the clean room. Sometimes specifications won't necessarily call out whether or not you need vertical or horizontal laminar flow, but we can help advise you into the direction if you're not quite sure. This is great for cleaning process piping, especially large process piping. So this was a 50 by 100 roughly ISO 5 clean room, and they needed to clean beam array tubes that were about 40 or 50 feet long, a couple tons. And so we had to clean these to a level that had never been achieved before. In order to do this, it didn't make sense to have air flowing down because really we're cleaning the inside of this tube. And that was what was required for the bigger picture. And so instead, we put the HEPA filters. We put the HEPA filters on this wall. The entire wall was made of HEPA filters. And it flowed all the way out until it exhausted all over here. Okay? And the thing that's great about this is as we clean this tube right here, it's going to be flowing laminar flow air, ISO 5 air, all the way out. And to the point where when we took a particle count at the end of this tube, because this whole tube was cleaned, it was also ISO 5. Horizontal or vertical laminar flow would not have provided the same purpose. Other applications like our mobile clean rooms that support semiconductor jobs and semiconductor manufacturing, those are going to be vertical laminar flow. Like I showed you at the table earlier, there are the eddies falling around it. We'll have perforated tables that you can place inside, and that's going to allow for clean air to flow through it. That's more for orbital welding. So there's a couple of different applications. Typically, what we're going to see, aerospace, it just depends whether it's going to be laminar flow or horizontal flow. Depending on the situation, you might need it, you might not. So really, talk to us if you're going to need it or not. So I'll just put sometimes it's laminar flow, blue for laminar, and sometimes you're fine with turbulent. The thing with aerospace is you're typically less concerned with sterility, whereas biotech, you're very concerned with sterility and pharmaceuticals as well. So this is almost always laminar flow is required, however, in a BSC. I'm just going to put a BSC right there. But for the room itself, you really don't need it. So for the most part, some applications, they might. It's very uncommon. So semiconductor, this is one. It just depends on what you're using it for. This is another situation where it's, let's talk about what you're doing. Let's talk about what process you're going to be using the clean room for, and we'll help you, get narrowed in. But really, in most cases that need perforated floor tiles and laminar flow all the way throughout the room, ISO 5, ISO 4 sometimes, this is kind of the zone that, the industry that's going to need most perforated floors and horizontal laminar flow. However, again, it depends on the situation. Give us a call. We'll talk through your project and get to know what you're looking for a little more. Anyways, if this video was helpful, I'm happy to talk about your guys' clean room needs and your upcoming projects. If you want, you can shoot me a call at 949-274-0165, or a text works just fine. We're happy to talk about what you guys are embarking on and help you out through the journey. I hope this video was helpful. If you have any questions, feel free to leave it in the comments or just go to instantcleanroomsolutions.com and we'll get in touch with you there. Thank you very much. Bye.